Hello everyone. In this session, we will see about mathematical model of a transportation problem. So let's consider a particular firm having m supply points, and in table we will represent those supply points in terms of rows, say S1, S2 and so on up to Sm, and n demand points. In a table we will generally represent the demand points in terms of columns. Here we are considering those demand points as D1, D2 and so on up to Dn. Let the supply quantities available be A1, A2 and so on up to Am respectively for those supply points, and the demand points let it be B1, B2 and so on up to Bn, which we'll be mentioning in the columns, right? So let capital X suffix ij be the quantity to be allocated from ith supply point to jth demand point. Generally, I is used for denoting any row and j is used for denoting any column. So here the I ranges from 1 to m and j ranges from 1 to n. Let Cij be the cost, C be the cost, and ij is the suffix. It is meant for what is the cost of transporting one single unit from ith supply point to jth demand point. So considering all these things, we can show all these things in one single table. So the table will look like this, wherein you have m supply points, S1, S2 and so on up to Sm, and in between I wrote it as Si, so that can be generalized to all the m supply points. Similarly, the demand points D1, D2 and so on up to Dn, and in between I mentioned it as D suffix j, which can be used to generalize all the demand points. So in all the previous problems, you might have noticed that in each cell, left top corner of each cell, we used to mention the cost. So this is located in first row, first column. So we call it as C11. Since this is located in ith row and jth column, we are mentioning it as C suffix ij. Similarly, the last cell, Cmn, because it is located in mth row and nth column, right? And then whatever we mention here, those are the allocations. In the sense here, I didn't mention it. So it should be 1, 2, suffix 1, 2. Yeah, I think the rest of the things I had mentioned already. So this X basically denotes your allocation. How much is the quantity being allocated? So generally in all our problems, we either mention with some number or nothing in that, or sometimes we put cross in that, which means zero allocations. That means all this X can take any positive quantity or it can take zero in it. So it is very similar to whatever we did numerical problems. Here it is being generalized because we are creating a model. That is the reason it is being generalized here. So these are the supply quantities as it is specified in the beginning. Supply quantities are denoted by A1, A2 and so on up to Am. Again, in all the problems, whatever we had seen some numbers in that. And then this demand B1, B2 and so on up to Bj, right? These are the things. So what is our objective? Our objective in any transportation problem is to minimize the total cost. How do we calculate total cost? We multiply each of the cost unit into the allocation. Means, for example, C11 into X11. Then we add C11 into X11 plus C12 into X12 plus and so on. C1n into X1n. And then we continue adding all those things after multiplication. That means I can generalize that as minimizing Cij multiplied by Xij. And we have two summations here. One summation is meant for I and one summation is meant for j. So that's what it is. Subject to what? Subject to first constraint is, see, for example, whatever allocations we are doing in the row, for example, Xi1 and then Xi2 and so on, Xin, this should add up to Ai. That's what is mentioned here. Xi1 plus Xi2 and so on up to Xin should match to Ai, right? So I can write, if you look into this, What is constant? I is constant, which is varying. The second suffix is varying, means j part is varying, I part is constant. So I can write it as xij. What is varying? J is varying from what to what? From 1 to n. So we are writing j equal to 1 to n. So simply we can write that as summation j equal to 1 to n. Xij should be equal to ai. Means this takes care of your one of the condition of your basic feasible solution, which is row constraints should met with. Means whatever we are allocating in the rows, in each row, that should match up with the total of that particular row, or it should match up with the supply quantity of that particular row. Similarly for columns, if I go into that table again, these sum means x1j, x2j, and so on up to xmj. If I add all those things, it should match your bj. This is applicable for all the b's. So I will say for all j. So that's what is written here. So x1j plus x2j and so on up to xmj should be equal to bj. Or I can simply, if I look into the first suffix is varying, second suffix is constant. So I write simply as xij, where I is varying from 1 to m, and that should match with bj. So that is another condition. Then another thing, we know that all the allocation should be non-negative, because quantities, those are all quantities. It cannot take any negative value, and it should be greater than or equal to 0. One more thing I missed to mention here, which is the fourth constraint, that is summation of your AIs should be equal to summation of your BJs. So this J is ranging from 1 to n, and I is ranging from 1 to m. So that is a must, means you are balancing that transportation problem before proceeding with finding what is the basic feasible solution. So this is basically a mathematical model. How do you generalize a transportation model? The first one, whatever I wrote here, minimizing, this we call it as objective function, and the rest are called as constraints or subject to some restrictions. We can call this one as non-negativity restrictions also. This also can be called as non-negativity restrictions. And the rest of the three we can call it as constraints. So this is about the mathematical model of a transportation problem. So by this, our videos in the series of transportation problem is getting completed. Subsequently, we'll meet up in some other new topic in our future videos. If you find this video to be useful, I request you to like and comment about the video. And also, if you have not subscribed yet, I request you to please subscribe to my channel so that you can get regular updates on the videos, whatever I am posting. Thanks a lot.